In this video, we will learn about how to find out the steady state capital labor ratio and real GDP per worker. The question is, find the steady state capital labor ratio and real GDP per worker from the following data. We have y is equal to k raised power 1 upon 3, s is equal to 0.42, depreciation is 0.25, and population growth rate is 0.03. Okay, so this y denotes output per worker is equal to capital labor ratio raised power 1 upon 3. That is our production function in intensive form. So savings rate is 42%, depreciation of capital is 25%, and population growth rate is 3%. Okay, we need to find out the steady state capital labor ratio. By steady state, what is meant by steady state? Steady state is a long run equilibrium where capital stock per worker and output per worker remains constant over time despite ongoing population growth and depreciation of capital. So at steady state, what happens? The change in the capital per worker is equal to 0. So at steady state, change in the capital per worker will be equal to, that will be equal to savings. So S denotes the savings rate times Y denotes output per worker minus del plus n k. Okay, and it should be equal to 0. So here it means that Sy will be equal to n plus del times k. So this condition must hold at steady state where the change in capital per worker is equal to 0. Now what does this equation tell us? At steady state, savings per worker is equal to, or it must be equal to, the investment needed to offset the depreciation and equip new workers. Okay, this is the fundamental equation of the solow model. Rather, this question is in fact about the solow model. So this equation tells us that savings per worker must equal to the investment that is needed to offset the depreciation and equip the new workers. That is why the capital change in the capital accumulation is equal to 0. Now we have the savings rate, or let us first solve it further. So we have S and Y is being given as k raised power 1 upon 3 is equal to n plus del times k. So transpose this k here, so we will get S k raised power 1 upon 3 upon k is equal to n plus del. We can rewrite it like this: k raised power 1 upon 3 upon k is equal to n plus del upon S. Okay, or transpose this to denominator, we will get 1 upon k raised power 1 times k raised power negative 1 upon 3 is equal to n plus del upon S. So here we will get same basis, we can subtract, so it becomes k raised power 2 upon 3 is equal to n plus del upon S. Now let us give the specific values here, or we can write 1 upon k raised power 2 upon 3 is equal to, so n, that is population growth rate, is 0.03, depreciation is 0.25, and savings rate is 0.42. So it will be equal to 0.28 upon 0.42, so it becomes 28 upon 42. So 7 4s are 7 6s are, which is equal to 2 3s are, sorry, 2 2s are 2 3s are. So here we have 1 upon k raised power 2 upon 3 is equal to 2 upon 3, reciprocate both sides, so we get k raised power 2 upon 3 is equal to 3 upon 2, or k will be equal to 3 upon 2. Transpose this here, it becomes 3 upon 2 exponent. This is our steady state capital labor ratio. Okay, now we also need to find out the real GDP per worker. So plug k is equal to this into the given production function, that means output per worker will be equal to k raised power 1 upon 3 which will be equal to K is 3 upon 2 raised power 3 upon 2, and here we have 1 upon 3. 1 upon 3 is the exponent, 1 upon 3. So it will become 3 upon 2 times 3 upon 2 raised power 3 upon 2 times 1 upon 3. 3 and 3 gets cancelled, so we are left with 3 upon 2 raised power 1 upon 2, which is equal to under root 3 upon 2. So a real GDP per worker will be equal to under root 3 upon 2 is 1.5. Okay, this is how do we solve for steady state capital labor ratio and real GDP per worker.